Good evening, students. Today I am going to teach you distance and displacement. Last class already I have given you the idea about the frame of reference. So let me brief it. Frame of reference is what? In relation to the frame of reference, we can say whether an object is in motion or it is at rest. So frame of reference, it is usually chosen your x, y and z axis along with a time at the origin. X, let's say this is z and this is y. Your x, y, z coordinates along with a time measuring clock constitute your frame of reference, and this is the origin or this is the reference point from which you are measuring. Clear? Or you are observing the motion of the object. Now let us come to the point, distance and displacement. Distance. Suppose there are 2 points. One point is A here, another point is B here. The means, let's say there are 2 different points on earth. So from here to here, you can take any path as you wish to reach B. Suppose you are here to reach B. Suppose you are taken, let's say this path. Someone taken a straight line path. Someone taken this kind of path. Got? So distance is what? This is the actual length of the path covered. Distance is what? It is the length of the actual path covered. The actual path length, it is called your distance. So from the 3 diagram, if you see the length of, means if you mark, this will be your path 1, this is path 2, this is path 3, means we can say the distance in path 1 must be greater than that of distance in path 3, must be greater than that of your distance in path 2. So this means distance is what is the actually length of the path covered. It will vary though the initial and the final point remains same. Got? Let us come to your displacement. So these are the terminology you must know to study the kinematics. Displacement is what? Again the same example you take. From A to B, the shortest path is, if you take a straight line joining these two, then the length of the shortest path will give you your displacement. Clear? The length of the shortest path is what? It is actually the straight line joining the 2 initial point and the final point give you your displacement. Clear? Actually, displacement is a vector quantity. In your latter chapter, you will see there are 2 classes of physical quantities. One class is called your scalar quantity and the other class is called your vector quantity. So let me elaborate what is a displacement actually means. So for that, let me take another example. Suppose you are here at point A. You need to go to point B. The distance in this path, in the straight line path, let's say it is 1 kilometer. The length of the straight line path joining A and B, it is 1 kilometer. So before going into that example, let me tell you about the direction we are going to take. This is your east direction, this is your west direction, this direction is your south and this direction is your north. Suppose you are at point A, you want to move to point B. Clear? So it means if you are at point A, yes, to reach point B, you need to move 1 kilometer distance along the direction of east. Got? So between A and B, you are moving along a straight path, but from A you are moving 1 kilometer towards east to reach the point B. If you change the direction, suppose same 1 kilometer, if you move along south, then you will reach some another point D. B and D are not the same 2 points, though this length is 1 kilometer, and this length is 1 kilometer. Though the length of the path here is 1 kilometer, here it is 1 kilometer, so clear got? But the direction of your displacement are different. Suppose someone is here, to reach the point B, you need to move 1 kilometer along east. You need to reach the point D, you need to move or you need to displace 1 kilometer along south. So that is a way where displacement has some direction. So to explain here, to explain the displacement term in a more elaborate manner, I can say, suppose one person is here, is moving to point B, and another person is moving to point D, choosing any path. Got? One person is moving in this way and it is coming to point B. Another person, it is moving here to here and it is coming, and again it is reaching the point D. So in this case I can say the person which is reaching B, the displacement is 1 kilometer east. Displacement is what? 1 kilometer east. The person which is reaching D, the displacement of that person is 1 kilometer south. 1 kilometer in the direction of south. Though these two are same, means the magnitude of the distance, means the magnitude of the line joining the 2 points A and B, they are same, but the displacements are different. And more elaborately, you see, the person has choosing this path, but the displacement is nothing but the length of the line joining the initial point and the final point. If you see about the distance is much more greater than the value of the magnitude of the displacement here. Clear? So the displacement of the person along this direction is 1 kilometer east and along this direction is 1 kilometer south. Clear? So in direction wise they are different. Also they are different from your distance, because you see distance is what? It is the actual length of the path covered. The length of line AB and this curved line, there is a huge difference. Got? So the length of this path, it is called your distance. Means if you chose this length of the path, it is called your distance, whereas the length of this AB, the straight line AB, is called your displacement. That is the basic difference between distance and displacement. Now let us solve a question related to distance and displacement. The simple question, if I solve that question, then you will get to know the difference between distance and displacement. Suppose an object is moving in a circular path with a constant speed. An object is moving. Suppose object is moving from here to here. Suppose initially the object is at A. It is moving to point B, again to point C and to point D, and again it is returning to point A. Got? Now my question is, at B, C and D, what is the distance and displacement? If the path is circular, the circle must have a radius R. So from A to B, so let us find out distance and displacement. At point B, point C, point D and point A. Distance is what? It is the length of the actual path covered. Clear? Actual path covered is what? A to B. Means if you see, if you move on a circular path from A to A, the entire length is 2 pi r. The entire length of the path is 2 pi r. And as this is a quarter of your perimeter, means this would be your distance at point B. Distance at point B, it would be 2 pi r by 4. So which is pi r by 2, means the entire length is 2 pi r, it is 1/4 of it, so it will be pi r by 2. Now at point C, it is half of the perimeter, so it would be that, so the distance would be simply pi r or 2 pi r by 2, which is your pi r. At point D, you see, it is 3/4 of the perimeter, means this entire length is pi r and this is pi r by 2. So at D, it would be pi r plus pi r by 2, so which is 3 pi r by 2. Now at point A, means it completes the circular path, so its entire length will be 2 pi r. Now comes to your displacement. Displacement is what? It is the length of the shortest path, or in simple way, you join the initial and final point. Initial point is here, final point is here. The length of that initial and length of the line joining the initial and final point gives you your displacement. This length is, it is r radius. This length is r. If you see some geometry, this angle is 90. R means this would be your r square plus r square's root over. So it should be root 2r. This would be how much? R square plus r square's root over, which will be root 2r. So displacement is, the magnitude of the displacement is root 2r. Now if the object is at point C, means if you join initial and final point, you will see it is nothing but the diameter of the circle. So the length of the diameter will be 2r. Now at this point, you see, if you join, you will find this chord here. You can also find this length will be r. If you join this, this will be also r. If this is r, this is r, this is 90 degree, and this will be again will be your root 2r. So at point D, your displacement will be root 2r. And at point A means the initial and final point both are same, so your displacement is 0. Clear? So from this question, it is very clear what is the difference between distance and displacement. Thank you.